Hello guys, welcome to the lecture 9 of machine learning series. In this video, we'll be discussing about another important topic, that is framing and machine learning problem. Now, before going into the video, we'll be seeing a quick glance on what we'll be discussing in this entire video. Okay, first we'll be seeing the introduction. Okay, we'll be seeing introduction on how and machine learning problem is framed, and then we'll be seeing a case study. Okay, for some time we'll be a data scientist of a company and how the data scientist converts a business problem into a machine learning problem. Okay, then we'll be seeing the types of problems. After conversion of this business problem into a machine learning problem, we'll be having sub problems in them. Okay, we'll be also discussing about them, and then we'll be seeing the next immediate solutions. Okay, next immediate solutions to that problem, and then we'll be discussing about the getting the data and choosing the right metrics problems, and finally we'll be checking our assumptions. We have figured out the machine learning problem, and we have also figured out the solutions to that machine learning problem. Okay, now after figuring out the solutions, are those solutions they will be suitable for that machine learning problem or not? Okay, they'll satisfy that business need or not? Okay, we'll be checking out those assumptions. Okay, now next it comes the introduction. Okay, now if you see this block diagram, okay, this is a machine learning development life cycle. Okay, we have discussed this block diagram in detail in our past videos. Okay, now if you see in this block diagram, our very first step is problem definition. Okay, this problem definition is nothing but framing and machine learning problem. Okay, this problem definition is nothing but framing and machine learning problem. Okay, now let's say as a data scientist, you're working in an organization. Now it is very important that, it is very much important that they'll be giving you a business need. Okay, they'll be giving you some business need, and as a data scientist you need to convert this business need. Okay, you need to convert this business need into a machine learning problem. Okay, this is basically what happens. Okay, this is basically what happens in an organization. Okay, till now what machine learning we have done, is just we have just framed our machine learning problem, and we have collected our own data set, and we have trained a machine learning model, and finally we got the results. Okay, but exactly this process doesn't happen in an organization. Okay, in an organization you'll be giving an business need, and based on the business need you need to convert that business need into a machine learning problem. Okay, even after converting that into a machine learning problem, you'll be having sub problems in them. Okay, you need to also find out the solution to that sub problems. Okay, now as a data scientist alone you don't work. You'll be given a team. Okay, you'll be given a team of data scientists, and each of you will work on different problems. Okay, this is basically what happens in an organization. Okay, let us see an case study. Okay, let us see an example case study. Now let's say you are a data scientist in a company called Netflix. In a company called Netflix, you are a data scientist. Now in the board meeting, where board members attend, they call you. Okay, as a data scientist they call you to that board meeting. Now what board members have decided is to increase the revenue of the Netflix. Okay, what board members have decided to increase the revenue as revenue of the Netflix. Now the board members had asked you what are the solutions. Okay, what are the current solutions that are available to increase the revenue of this Netflix. Okay, as a data scientist you are given 3 possible solutions. Now the first possible solution is to increase the customers. Okay, to increase customers. Okay, to increase the customers or to increase the number of subscriptions to the Netflix. The second solution you given is to increase cost. Okay, the second solution is to increase the subscription cost, and third is to decrease the number of users leaving the platform. Now these are the 3 solutions. Okay, these are the 3 immediate solutions that came to your mind. Okay, first is to increase the number of users, and second is to increase the subscription cost, and third is to like decrease the number of users leaving the platform. Okay, now if you see the first two solutions, okay, the first two solutions are little difficult. Okay, now immediately increasing the number of customers is like impossible task. Okay, now secondly, to increase the cost of the subscription. Now when you increase the cost of the subscription, more numbers will be leaving the platform. Okay, your revenue may be increased in the short term, but when you see in a long term, okay, when you consider long term solution, when you consider this as a long term solution, it definitely fails. Okay, so these two solutions are not immediate solutions to this problem, okay, to this business problem. Now the third solution is to decrease the number of customers leaving the platform. Okay, to decrease the number of users leaving the platform. Okay, now this is basically called, okay, this third solution is basically called churn rate. Okay, this churn rate is defined as, okay, this churn rate is defined as number of customers leaving a platform over an period. Okay, this is basically called churn rate. Okay, now how churn rate, okay, how decreasing the churn rate will increase the revenue. Okay, now let us say in a Netflix organization we have 1000 members. Okay, we have total 1000 people using Netflix. Okay, let's say in entire Netflix organization we are having 1000 subscriptions. Okay, now and churn rate is defined as 2%. Okay, let us say monthly churn rate is 2%, means every month 2% of the people will be leaving the platform. Okay, if we let's say we are not considering number of new customers adding, we are just considering number of customers leaving the platform. Okay, let us say in a Netflix platform there are no new customers adding. Okay, there are 0 new customers adding every month. Okay, and we are considering churn rate as 2%. Okay, now let us calculate this churn rate. Now 2 divided by 100 into 1000. Okay, as there are 1000 users, we are considering it as 1000. So this comes out to be 20. Means in this month, okay, in the current month of July, let's say we are considering July, we have 1000 customers. Now when it comes to next month, okay, when it comes to next month, that is August. Sorry, when it comes to August, I am having 1000 minus 20, that is 980 customers. Okay, now from 1000 customers to the next month I am only having 980 customers, means the total customers are decreasing. Okay, now at this 2% rate, if number of customers decrease, every month I'll be losing 20 customers. Okay, every month I'll be losing 20 customers from that total number of customers. So finally at some point, okay, finally at some point I'll be having no Netflix users in my platform. Okay, this is basically what happens. Now as a data scientist, okay, now as a data scientist, what you need to do is you need to decrease this churn rate. Okay, you cannot make it exact 0, but you need to decrease this churn rate. Okay, now let us say now when we see the current statistics, the current Netflix churn rate is 5.5%. Now as a data scientist, what you need to do, what you have decided to do is you need to make it to 5.2%. okay, the 0.3% change is very much huge. Okay, this 0.3% change is very much huge, as because Netflix is a bigger organization and will be having some millions of people. So 0.3% change is also a considerable change. Okay, so as an data scientist, what you have decided is to decrease this churn rate from 5.5% to 5.2%. okay, 5.5% to 5.2%. okay, now from where like you have started, okay, you have started from a business problem called, okay, this PP specifies the business problem. Now what's your business problem? To increase the revenue, to increase the revenue of the platform. Now you have converted that to a machine learning problem where you need to decrease the churn rate from 5.5% to 5.2%. okay, you have successfully converted, okay, you have successfully converted as a data scientist from business problem to a machine learning problem. Okay, this is basically the case study of an framing and machine learning problem. Okay, you have successfully framed and machine learning problem. Okay, now let us see, okay, let us see how this problem, okay, this machine learning problem has sub problems in it. Yeah, as a data scientist, you have successfully framed and machine learning problem. Okay, you have successfully framed and machine learning problem. Now this machine learning problem also has some sub problems divided. Okay, this machine learning problem is not alone a machine learning problem. Okay, you'll be having some subdivisions to it. Okay, you'll be having some subdivisions to it. Okay, now the very first subdivision, okay, we'll be understanding this very first subdivision with an example. Now you basically want to decrease the churn rate. Okay, this is basically your machine learning problem. Okay, you want to decrease the churn rate. Now to decrease this churn rate, okay, to decrease this churn rate, you want to know, okay, among all the users, you want to know who leaves the platform and who doesn't leave the platform. Okay, now based on maybe watch time or some other data, you want to know, okay, you basically want to know who leaves the platform and who doesn't leave the platform. Means, let us say we have 1000 customers in Netflix. Okay, we basically have 1000 customers in Netflix. Now out of this, let's say we are considering each customer as an individual. Okay, we are considering each customer as an individual, and we are trying to figure out whether that customer, okay, whether that user want to leave the platform or he want to stay in that platform. Okay, whether he want to leave the platform or whether he want to stay in that platform. Okay, based on that we are doing some classification. Okay, you can see that we are segregating the customer into two classes. Okay, whether he want to leave or whether he want to stay in that platform. Okay, you see that we are doing segregation, means it is a classification. Okay, now when we say classification, what comes into our mind? Supervised learning. Supervised learning. Okay, now we have successfully divided. Okay, first we have figured out our machine learning problem, and from that machine learning problem we have got that this problem type is an supervised learning, and from supervised learning we have figured out that it's a classification problem. Okay, this is the first step. Okay, this is basically first step. And second, okay, second, now to prevent that customer, okay, to prevent that customer leaving that platform, what we basically do, we can offer discounts, right? Okay, we can offer discounts to that customer so that he doesn't leave the platform. Now to offer discounts, we can't offer the same discount to the person who has less willing to leave the platform to the who has more willing to leave the platform. Let's say a person, okay, a person named A like watches 2 hours of Netflix content. Okay, watches 2 hours of Netflix content. Okay, now the probability of this person to leave the platform is around 0.3%. Okay, the probability that this person A wants to leave the platform is 0.3%. Now the amount of discount you offer to this person will be definitely less, right? Okay, will be definitely less. Now let's say a person B, let's say a person B, yeah, let's say a person B watches just 30 minutes of content. Okay, watches just 30 minutes of content. Now the probability of this person leaving the platform is around 0. Let's say 0.8%. Okay, as he watches less time, okay, as he spends less time in the Netflix per day, we are considering 0.8 as the probability that this person leaves the platform. Okay, now the amount of discount you offer to this person will be some high, okay, somewhat better than the person A. Now let us consider another person C. Okay, now this person basically spends 5 minutes, okay, just 5 minutes on Netflix. Okay, now the probability of this person leaving the platform is around 0.9%. that is 99% we are sure that next month, okay, next month this person will be leaving the platform. Okay, so the amount of discount you offer to this person is definitely very much higher. Okay, now so based on this probability you are offering the discount, so you can see that this is an regression problem. Okay, first, in our initial assumptions, okay, we have figured out that it's a machine learning problem. Okay, we have successfully figured out our machine learning problem. Now from that machine learning problem, we have figured out it is supervised learning. Okay, we have figured out it is definitely supervised learning. Now from supervised learning, we have initially assumed that it is classification, but we have we have modified. Okay, we have, let's say, from classification, we have again figured out that it is regression. Okay, it is regression. Okay, from supervised we have gone to classification. Now we thought that classification is wrong, and then we have came to regression. Okay, so in this way you initially define the problem. Okay, initially you define the problem. Okay, whether it's supervised or unsupervised or semi-supervised or reinforcement learning. Now after you figured out which type of problem, then you will be again do the subdivision, whether it is a classification or it is a regression. So in this way you will be again finding out what type of problem. Okay, so this is basically different types of problem. Okay, firstly you will be finding out machine learning problem, and then supervised or unsupervised or semi-supervised or reinforcement, and then in that you will be finding out whether it's classification or regression. Okay, now this is the very first step. Now after that, okay, we need to consider various constants. Okay, now the various constants are the watch time. Okay, in various constants we have watch time and the subscription cost. Okay, these are also this all affects the churn rate of an company. Okay, these affect the churn rate of basically Netflix. Okay, now second is, okay, now this second is, define objective. Okay, what objective? Okay, what's our basic motive? Okay, our basic motive is to decrease the churn rate. Okay, why need to decrease the churn rate? To increase the revenue of the Netflix. Okay, this is our major objective. Okay, this is our major objective. Now here comes the basically we'll be discussing about the data. Okay, we'll be seeing it in the next slide. Now about metrics also we'll be discussing in our next slide, and potential impact. Okay, now after figuring out different problems and solutions, does this solutions and the figured out problems will affect, okay, how much they'll affect the current business need. Okay, how much they'll be showing the impact on the current business need. Okay, about that we'll be discussing in the potential impact and ethics. Okay, now yeah, when it comes to different types of problems, getting the right data is also a problem. Okay, now as a data scientist, you don't just gather the data. Okay, there will be a separate team available for gathering the data. Okay, what as a data scientist you need to do is you need to consult the team. Okay, you need to consult the team and gather the data. Okay, you need to explain entirely what's your business problem and what's your machine learning problem, and what are the subtypes in it. Okay, either it may be supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, or in supervised learning, is it regression or classification. So if you explain, okay, if you explain the existing research work you've done, so based on that the team will be giving you the data. Okay, now the data, okay, let's say in the data we have like, okay, let me just select this pen. Okay, now the first column would be in the data. Okay, in that given data, the first column would be watch time. Okay, definitely it would be watch time in any streaming platform. Okay, second is let's say per user. Okay, let's say a person is watching a movie of which is 2 hours. Okay, now he has watched for 10 minutes and he has left the movie in the middle. Okay, so what as a data scientist you may assume is, okay, as an initial assumption you may assume is he may not have not liked the movie, and he might have left the movie. Okay, he might have left the movie in the middle. So there's a chance that, okay, there is a chance that, okay, I don't say it as confirmed, but there is a chance that next month he might have left the platform. Okay, he might have left the platform. Okay, so out of total watch time, okay, out of total length of the movie, how much amount of movie, okay, how much duration of the movie a person watch is also an important feature. Okay, now the third is when you click a movie, okay, when you click a movie in Netflix, you'll be seeing that under that we'll be having some recommendations, right? Now, out of total recommendations, okay, out of total number of recommendations, how many recommendations that the user has clicked, okay, how many total recommendations that the user has clicked, okay, even that also matters, okay, for this. Now let's say a person has made 100 searches in the Netflix platform, okay. Now out of 100 searches, there might be some few movies there may be few movies that are available in the Netflix, and there may be some other movies that are not available on the Netflix. So if there are, okay, now let's assume that out of 100 searches, the total number of movies that are not available, okay, the total number of movies that are not available on the Netflix are more, okay, let's say they are more. So there's a high probability, okay, there's a high probability that the person might leave the platform next month, okay. So in this way you'll be figuring out the entire data, okay. In this way you'll be getting the sample columns, okay, not only these 4 columns, but you'll be getting some hundreds of columns from the team, okay. Now after getting this data, what as a data scientist you need to do is you need to basically clean the data, okay. You need to do feature engineering and preparing the new columns and dropping few columns, and you need to like fix the date type issues, and you need to remove the null values. So in this way you need to entirely work on the data, okay. As a data scientist you need to entirely work on the data, okay. This is basically getting the right data problem, okay. Yeah, next comes metrics to measure, okay. What are the metrics I need to consider? Now let's say I'm assuming the problem as classification problem, okay. Under supervised I'm assuming it as a classification problem. Now when you assume it as a classification problem, the metric should be either confusion matrix or it may be accuracy score. Now let's say I'm assuming it as regression problem. Now when you assume this as a regression problem, you need to consider loss, okay. You need to basically consider loss, okay. Now in this way, sorry, you need to basically consider it as loss. So in this way you need to select the right matrix, because selecting the right matrix is very much important in training and machine learning model, okay. If you don't choose the right matrix, the machine learning model would definitely be trained in the wrong direction, okay. So it is very much important. Choosing the right matrix is very much important, okay. So I want to specify that I have missed one thing, that is batch learning versus online learning, okay. Batch learning and online learning, okay. Even this is also very much important in different types of problem, okay. Now after defining that problem, machine learning problem, you need to also specify that whether this machine learning model, okay, whether this machine learning model will be trained under batch learning or online learning, okay. Now let's say let's consider Netflix, okay. Let us consider a Netflix model, okay. We have built an Netflix model. Now we have deployed it on the server, okay. Now let's say we are using batch learning. Now let's say in a week, okay, in a week we'll be having weekdays and weekends, right? Now during weekdays, okay, during the weekdays, the persons that are who stay at home, okay, the persons who stay at home basically watch the content, okay. Now the students and like IT professionals or some government employees definitely will be going to the offices or schools or some colleges, okay. So who stays at home? Basically mostly women, okay, mostly women and some other old age people. So based on that, okay, based on that you need to recommend the content, okay, based on that age group, okay, based on that age group or gender, you need to basically recommend the content, okay. Means during the weekdays, okay, during the weekdays you are recommending some content, and during the weekends, okay, during the weekends basically students and other IT professionals will be watching the content. So they basically watch some anime or some like science fiction movies, okay. So in this way, based on their taste, you need to recommend the movies. Means during the weekends some let's say the content is changing, and during the weekends the content is changing. So training it as a batch learning, okay, training under batch learning is not possible, because under batch learning we basically train a machine learning model over a period, okay. First you will be deploying it on the server. Now over a period, let's say we have set a 1 month period. After 1 month you will be bringing the machine learning model offline, and again you will be retraining it, and again you will be deploying it on the server, okay. So this is not possible in case of Netflix, okay. So now when it comes to online learning, we will be basically training when the machine learning model is on the server, okay. You will be doing continuous training, okay, let's say new movies are added, okay, let's say new movies are added on the Netflix, okay. So when the new movies are added on the when the new movies are released, okay, when the new movies are released, you need to make sure that new movies are available on the Netflix platform, okay. So for that, what you do is you basically take the machine learning model when it's on the server, okay, when it's online, and you'll be training with that new data, okay, you'll be basically training with that new data. But when it comes to batch learning, what you basically do, let's say in the month of June, okay, in the month of June we have a movie release, okay, but we have set, okay, we have set 1 month duration, okay, for training that model. We have set 1 month duration, so this movie will be available on the Netflix on July, okay. This is basically how batch learning works, okay. This is the difference between batch learning and online learning, okay. After figuring out the machine learning problem, you need to also assume that whether this model is best suitable for batch learning or online learning, okay. Now when it comes to solutions, we'll be having two types of solutions. First is current or immediate solution, okay, current solution or immediate solution, okay. For increasing the revenue, okay, for increasing the revenue of the Netflix, what might be the current solution, okay, current in hand solution, okay. The current solution will be definitely offering discounts, okay, offering discounts or lowering the discounts, okay, offering the discounts or lowering the price of the subscription, okay. This is the current available solution. But the long term solution would be definitely long term solution, okay. This is the second type of solution, okay. The long term solution would be definitely adding the more regional content, okay. Now when it comes to India, we'll be having various various people who speak different languages, right, okay. We'll be having various people who speak different languages, okay. So they watch different content, okay. In each state they watch different content, so adding more regional content, okay, adding more regional content will definitely increase the revenue of the Netflix, okay. Why I don't say this adding the local content as a current or immediate solution is because in Telugu we'll be having some 20 movies, okay. Let's say we want to add, okay, sorry, we basically want to add some amount of movies on the Netflix, okay. Let's say there are 100 movies, okay. We basically want to add 100 movies per day, okay. Now adding 100 movies per day means we'll be having in Telugu we'll be having 20 movies, in Marathi we'll be having 20 movies, in Hindi we'll be having 20 movies. So as there are different languages, okay, as there are different languages, so total number of movies increases, okay. So continuously adding this local content is very much impossible. So this is a long term solution, because you basically add some set of movies, okay, some set of movies in Telugu, let's say 4 movies per day in Telugu, and 4 movies per day in Hindi, and 4 movies per day in Marathi. So in this way you'll be adding few some set of movies, okay, some set of movies every day, okay. And you cannot add some large, okay, bulk number of amount of movies onto Netflix at a time. So what you do is you divide and add onto the Netflix. So this is a long term solution, okay. The current solution would be definitely offering the discounts or lowering the cost of the subscription price, okay. Now after figuring out the solutions, okay, the next would be checking your assumptions, okay. Now let us say the built model, okay, the built model for Amazon India, okay, the build model for Amazon India may not work for the built model for Netflix India may not work for Netflix US, okay, may not work for Netflix China, or may not work for Netflix Indonesia, may not work for Netflix Russia, okay. Now the model I built in India will be definitely working in India, okay. So I need to make assumptions, okay, I need to make assumptions based on the country, okay. Now the built model in India will be definitely working in India. Now this model can be used, okay, I need to assume that it can be used or not, okay, it can be used in the US or not, okay, or it may be used in the China or not. So in this way we need to make assumptions, okay, on the model we built we need to definitely make few assumptions, okay. This comes under check your assumptions. Okay, first we build a machine learning model. Okay, after defining the machine learning problem, we will be building a machine learning problem. After building a machine learning problem, after building the machine learning problem, we need to assume that, okay, we need to check our assumptions that this built machine learning model will be working in India. Okay, definitely will be working in India. Now this built machine learning model will be working in any other country or not. Okay, now it may be working in some other country, like where there is more local content. Okay, where there is more number of languages and more number of people watching the local content. Okay, but globally, when we consider, most of the people watch English content. Okay, so in this way we need to check our assumptions. Okay, so in this video we have successfully taken a business problem and we have converted it into a machine learning problem. Okay, so hope you guys like this video. If you like the video, please like, share and subscribe. Thank you.